Very good morning. Let us continue our discussion of set theory in discrete mathematics. Today's contents I derived from this link storyofmathematics.com. So if you remember, we had seen various operations, set operations, starting with A union B, which indicated that elements are either in A or in B or in both. This was it. If there is set A and if there is set B, then the resultant is this set. Union is this. Intersection is those elements which contain in both A and B. So if you look at the intersection, we have only 1 and 3. Difference, you can see the difference here as, suppose set A is 1, 3, 5, set B is 1, 2, 3. Then the difference is 5. Then we had seen the universal second complement. So in continuation of that, let us try to understand symmetric difference. Okay, what symmetric difference indicates? Elements are present in A or B, but not in A and B. Let us say we have two sets A and B. The symmetric set or the symmetric difference set would consist of all elements either present in A or B, but not in the intersection of A and B. The symmetric difference symbol is this, and symmetric difference can be represented like this. Symmetric difference of set A and B is A union B minus A intersection B. Let us take A is a set consisting of the elements 2, 6, 7, 9. B is a set consisting of the elements 2, 4, 6, 10. Okay. So what is the symmetric difference? The symmetric difference is 4, 7, 9, 10. The symmetric difference is 4, 7, 9, 10. Symmetric difference is also called as disjunctive union. Okay. So how do I derive it? Let us say A is a set, B is a set, and this is the relationship which holds symmetric difference of B and A. So B union A minus B intersection A. So if you take B union A, so B union A will be 2, 4, 5, 6, 7, 8. B intersection A will be 2 and 8. So difference of 2, 4, 5, 6, 7, 8 and 2, 8 will be 4, 5, 6, 7. So this is the symmetric difference of B with respect to A. Same holds for this symmetric difference of A with respect to B. And this is the Venn diagram for the symmetric difference. This is the shaded part. Let us look at the few of the properties. Commutative loss A union B can be represented as B union A. A intersection B can be represented as B intersection A. De Morgan's law. Complement of A intersection B can be represented as complement of A union complement of B. Complement of A union B can be represented as complement of A intersection complement of B. Now, the below contents are derived from this link, mathonlymath.com. So, what the De Morgan's law says, as per De Morgan's law, the complement of union of two sets, the complement of this one. What is this? This part. This is A union B, and whole is the complement. So that's what it is saying here. The complement of union of two sets is equal to the intersection of their complements, individual complements. So what is this here now? A complement intersection B complement. So you can say this here as the complement of union of A and B is equal to the complement of A intersection complement of B. Similarly, the complement of A intersection B will be equal to the complement of A union complement of B. So these are called as De Morgan's law of union and De Morgan's law of intersection. So let us try to give the proof. What we have to prove? We have to prove this. And what is this? We have taken A union B first, and the entire A union B is complement we have taken. So this is complement of A union B. Now what we should prove that it is equal to A complement intersection B complement. Okay. So let us see how this proof goes. Let P is equal to A union B complement, and let Q is equal to A complement intersection B complement. Let X is an element which belongs to P such that X belongs to P. If X belongs to P, what it indicates? X belongs to A union B complement. If X belongs to A union B complement, X does not belong to A union B. If X does not belong to A union B, X does not belong to A and X does not belong to B. Here AND is important. See here, union and AND is important. So it means what? X belongs to A complement and X belongs to B complement. It means what? X belongs to A complement intersection B complement. If X belongs to A complement intersection B complement, X belongs to what? X belongs to Q. So what this indicates? This indicates that P is a subset of Q. Now similarly, we'll take a Y element and we say that Y is an element of Q. So if Y is an element of Q, what Q is represented? Q is represented as A complement intersection B complement. So it indicates what? Y belongs to A complement intersection B complement. So it means what? Y belongs to A complement and Y belongs to B complement. It means what? Y does not belong to A, Y does not belong to B, and here and is important. It means what? Y does not belong to A union B. It means what? Y belongs to A union B complement. So if Y belongs to A union B complement, Y belongs to P. So therefore Q is a subset of P. So now from 1 and 2, once we prove that P is a subset of Q and Q is a subset of P, we know that they both are equal. If P and Q are equal, we know that A union B complement is equal to A complement intersection B complement. Let us take the second one. We have to prove that A intersection B complement is equal to A complement union B complement. Same thing we'll do. Let M is equal to A intersection B complement. N is equal to A complement union B complement. X is an element which belongs to M. If X belongs to M, X belongs to A union B complement. A intersection B complement. If X belongs to A intersection B complement, it does not belong to A intersection B. If X does not belong to A intersection B, X does not belong to A, or here R is important, X does not belong to B. So it means what? X belongs to A complement or X belongs to B complement. It means what? When it is R, we can say that X belongs to A complement or B complement. It means what? X belongs to N. So what is proved? M is a subset of N. Similarly, what can be proved vice versa? That N is a subset of M. And once we prove that M is a subset of N and N is a subset of M, we know that both are equal. So M is equal to N. If M is equal to N, what is equal to what? A intersection B complement is equal to A complement union B complement. Let us take, there is a universal set called as U having the elements JKLMN. X is a set having the elements JKM. Y is a set having the elements KMN. What we have to prove is X union Y complement is equal to X complement union Y complement. So let us take X intersection Y. What is X intersection Y? X is JKM and Y is KMN. So we have to take JKM and KMN intersection. So if you take the JKM and KMN intersection, what we get? We get K and M. Okay. So this is the resultant of X intersection Y, K and M. So now X intersection Y complement will be what? Other than Km. What is other than Km? So other than Km will be JLN. So the complement value will be JLN. Similarly, if X is JKM, X complement will be Ln. If Y is KMN, the Y complement will be JL. So X complement union Y complement will be what? So that will be Ln complement JL. So Ln complement JL will be JLN. So if I look at 1, I know that X intersection Y complement is JLN. And if I look at 2, I know that X complement union Y complement is JLN. So both are same. So it is proved that X union Y complement is equal to X complement union Y complement.